Okay, hello everybody and welcome to lesson 8.5 in mathematics for grade 10 edit. In this lesson we will talk about solving linear and non-linear systems. Sometimes we'll be solving linear, non-linear together, so let's see this. In previous classes we have learned how to solve equations together, sometimes solving linear equations together, three equations together with three variables, two equations with two variables. But in here we'll talk about solving sometimes linear equations with quadratic equations together, quadratic with a quadratic. So let's see that. So in here in the first part, we will learn how to solve systems of linear and non-linear equations and or algebraically and graphically. So I'll be solving them algebraically and graphically. In the second part, solving systems of linear and non-linear, but in here inequalities graphically. Okay, so we need in the second part we need this most sometimes we can use it for graphing. So and you already know to find or yes, to find the equation or the graph of the equation by using this. Okay, so in here systems of equations. So in here first example, so when a system of equations consists of a linear and a non-linear equation. I mean by non-linear in here we'll talk about quadratic. So the system may have 0, 1 or 2 solutions. Some of the possible solutions are shown below. So sometimes we will have one solution, sometimes we'll have no solution, like in the first graph. As you can see, there is no intersection. In the second graph we have just one intersection point, so we have one solution. In the third graph we have two intersections, so we have two solutions. So in here that leads us just to solve or starting by in here solving linear with a quadratic system. Okay, now algebraically we are talking about solving algebraically. So in here, for example, if we have example like this, first equation, which is in here, as you can see, this is quadratic, 9x squared plus 25 y squared equal to 225. Okay, the second one, which is 10y plus 6x equal to 6. Now solve the linear equation for y. Okay, so first of all, I'll start. Usually, we are solving these types of equations by using substitution, not elimination. It will be the easiest method for us if we are using just the substitution. So I'm going to use the linear equation, okay, to substitute in the quadratic one. So what I mean by that? So first of all, start by solving the linear equation for one of the variables, x or y. Okay, so in here we are going to solve the first or the second equation here because it's the linear one. Okay, I'll solve it for y. So moving the 6x to this side, okay, that will give me 6 minus 6x. Okay, after that dividing by 10 all the sides, so that will give me y equal to minus 0.6x plus 0.6. Now instead of this y in the first equation, I'm going to substitute minus 0.6x plus 0.6. Okay, and after that I have a perfect square, so I can do it. The first one squared plus 2 multiplied by the first by the second plus the second one squared, which is 0.6 squared. So after that, just simplifying, and be careful once you are doing the perfect square, still we have 25 outside. So keep the parentheses, then after that enter the 25 by using distribution property. Okay, so after that just enter the 25 inside by multiplying it by each one of the terms in here. Okay, now after that just adding the similar terms together, so 9x squared which is equal to 18x squared minus 18x plus 9. We can in here, for example, so this is just a quadratic equation, we can solve it actually. Okay, so after that I'm going to take that 225 to this side. Okay, so then I can, for example, divide the whole equation by 18. Okay, just to make it easier, then just solve the quadratic equation, which is factorizing. That's it. Okay, so two numbers, their multiplication equal to minus 12, their summation equal to minus 1, and these two numbers are minus 4 and plus 3. That's it. Done. Done. Okay, so after that, just if you would like, in here we have so x, which is equal to 4 or minus 3. So this is for x. Okay, now we need to find the value of y. To find the value of y, okay, I can just use the direct substitution in this equation, okay, which we found at the beginning, at the first part. Okay, so substituting 4 first and then minus 3 the second one. So because we have in here two values for x. So after substituting the two values, we will have also two values for the y, which is 2.4 and minus 1.8. Okay, so these are in here two questions. Try to solve them. Okay, different level of difficulties. Try to solve the second one. Okay, so if you have any question in these questions, just ask me directly. Right, what if we have a quadratic and a quadratic? Okay, so two equations and both of them quadratic equations. Now in here, it's up to you. Okay, if you would like to use substitution, you can. If you would like to use elimination, you can. So if a quadratic system contains two conic sections, the system may have anywhere from 0 to 4 solutions. So starting by 0 to, so we can reach to 4 solutions in here. So in here, for example, no solution. In here, one solution. In here, two solutions. In here, three. In here, four solutions. Four intersections. If we have, I'm talking about two quadratic systems. Okay. So in here, let's see just this example. Okay. So in here you can see these two equations. So in here the first one is quadratic and the second one is quadratic. Now for me, I'm just going to use the elimination. So for elimination, I'm just going to make I'll choose one of them, x or y. Okay, and I decided just to make them. So for example, if I choose in here x, I'm just going to make the x's with the same signs. Okay, sorry, with the same coefficients but opposite signs. Same coefficients but opposite signs. And here the coefficient is 1. And here the coefficient is 1. And here the coefficient is positive. Okay, so it's positive in here, and in here it's negative. So done. No need for doing anything actually. But in here, if I choose y, by the way, and here the coefficient is 1, the coefficient is 1, but they have the same sign. So I would say that I can multiply this equation, either this equation by minus or this equation by minus 1. Anyway, so in here the easiest or the easier for me is just choosing the x's, okay, because they are ready actually. So in here, I'm just going to add the equations together. So x squared with x squared eliminated, y squared plus y squared is equal to 2y squared, 45 plus 27 is equal to 72. So at the end, square root, and don't forget that we have positive and negative. So after that, since we have two values for the y, we can also find two values for the x by using this equation or this equation. Okay, so direct substitution in one of them, and that will give you at the end in here, of course, here we have two solutions for y, which is positive negative 6. Okay, so direct substitution, so substitute 6 and minus 6 into one of the original equations and solve for x. So in here, after substituting, you can see that x is equal to positive negative 3. That's it. So after that, we will have positive 3 with 6, okay, and negative 3 with 6, and also we have positive 3 with minus 6 and negative 3 with negative 6. Be careful with that. That's it. Okay, so these in here as well, we have these two practices, so just try to solve them. Once you finish, tell me if you have any question about them. Okay, good. So in the second part of our lesson, in here we are going to talk about systems of inequalities. So usually in systems of inequalities, what's the procedure for solving any system like this. So basically I'm just going to graph the first one, then graph the second one. طبعا after graphing the first one, find the solution region. After graphing the second one, find the solution region. Then at the end, just find the intersection region. So in here, for example, solve the system of inequalities by graphing. And here, the first one we have inequality. It's for circle, okay, and the second one, which is for hyperbola. Okay, so basically all I have to do is just graph each one of them. So once you are graphing the first one, which is for a circle, and here since we have an equal sign after graphing the circle, this it will be solid. For the second one, after graphing the hyperbola, this it's going to be dashed. Now after that, after graphing the circle, for example, I will take 2 points if you are graphing manually, one of them outside the circle, one of them inside, and to see, come on, substitute them in the original inequality to see which one of them is correct. Okay, now if the inside or the point which I took it from inside, from the inside of the circle is correct, then I'll say that my solution region for the first inequality, it will be inside the circle. The same thing for the hyperbola. I'll take 2 points, one of them outside the hyperbola and the second one inside. Substitute in the inequality and see which one of them is correct. That's it. After that, the solution region, it will be the intersection region. That's it. Done. Done. Okay, which is the green region here. Actually, we can do this on Dismos as well. If you are doing this on Dismos, the same thing, you can find the intersection region. Okay, so just to try to solve these two questions, okay, as just practicing on this. The same thing if we have quadratic with absolute. So in here, if you are solving this question manually, actually, you already know that to graph the absolute value function. Okay, so in here, first of all, I need to find the vertex. So the vertex, it's going to be equal to x minus 4 equal to 0. So that will give me 2x equal to 4. And that will give me x equal to 2. Since we don't have anything in here as case, so our vertex, it will be 2 and 0. Okay, which is, that's it. So because in here k is equal to 0, nothing added to the absolute value function. You remember that from the 9 elite type. Okay, so after that, just graphing the absolute, taking 2 points, one from inside, one from outside, just to see where is my solution region. The same thing for the second question or the second inequality, which is for a quadratic equation. So graph it and find the solution region, and the intersection region, it will be the solution region. That's it. Okay, now just for finding the solution on this must will be the same. So in here, our first equation, it will be, or inequality, it will be y greater than or equal. Okay, so absolute value in here, we have what, 2x minus 4, 2x minus 4, that's it. Okay, the second inequality, which is y less than or equal minus x squared plus 4x plus 2 plus 4x plus 2. Okay, so this is the intersection region. You can find the vertices actually. That's everything. Done. Done. Okay, so let's see if you can do this. Okay, so by using this or manually, okay, try to solve these two questions at the end. And if you have any question about anything in here in this lesson, just ask me and I'll answer you there.